Okay, let's look at this grade 10 calculation. It's a stoichiometry calculation from November 2016. So over here, you can see over here, I've got all the information I'm going to need from the periodic table. I've got all the elements involved here, and I've got all my formulas from my formula sheet so that we can get started. Okay, it says to you, the empirical formula of a certain compound is to be determined. On analysis of a sample of the compound, it was found to contain 40% carbon, 6.6% hydrogen, and 53.3% oxygen. Define the term empirical formula. Well, empirical formula is the simplest whole number ratio of atoms in a compound. So it will just be all elements in the compound in their simplest ratio. It says determine the empirical formula of the compound, show all the calculations. So the first thing that we have to do here to do this is we are going to assume a 100-gram sample, because if we assume a 100-gram sample, we can equate the masses to the percentages. Okay, so what elements do we have? We've got carbon, hydrogen, and oxygen. So we're going to make a little table here. Okay, so if we assume an 100-gram sample, the mass in grams of carbon is 40, because that's what the percentage is. Hydrogen is 6,6, and the oxygen is 53,3. So the mass is helpful, but what is more helpful in every chemistry calculation is the number of moles. So if we want the number of moles of all of these atoms, we can use the formula N equals M over M, where it's the mass over the molar mass. So for carbon, it's going to be 40 over, and check here from the periodic table here. The periodic table here, carbon weighs 12, so this is 40 over 12. So this gives you 3,33333 recurring, yes? Hydrogen, the mass, 6,6 grams over the mass of a hydrogen atom. Well, hydrogen atom weighs 1, so this is 6,6. And then for the oxygen, if we've got 53,3 grams, one oxygen atom, as you can see over here, this has a mass of 16. So if we work this out, 53,3 divided by 16, we get 3,3125. Okay, we'll leave it as 3,31. So now these are big numbers in a ratio. We need to make it the smallest, simplest ratio. So now what we have to do is we have to divide by the smallest number. Okay, and if you have a look here, you can see I've got 3,3, 6,6, 3,3. We're going to divide by 3,3, and if you work it out exactly on your calculator, you'll get something like 1,006, like this. Okay, this one's going to be this one's going to be 1,99, and this one is going to be 1, because this was actually the smallest number. So if you have a look here, this will easily round off to 1, this will round off to 2, and this is 1. Okay, so we've found the simplest ratio, but we have not shown the empirical formula, so we have to show the empirical formula. So we know we've got one carbon atom, we don't write the 1, to 2 hydrogen atoms, to 1 oxygen atom. So that will be my empirical formula, CH2O. Now it says to you in 8.1.3, it says to you, if the molecular mass of the compound is 60 grams per mole, calculate the molecular formula of the compound. So now remember now, this empirical formula, CH2O, this is the most basic formula. It's actually multiplied by some certain number N to give you the molecular formula. Okay, so it's now our job to find what that N is. So if we have a look here, whatever the molecular mass is will be the empirical formula times N. So what is my the molecular mass of the empirical formula? So we can call this the empirical mass. Okay, so the empirical mass is the simplest ratio. So we've got 1 carbon, 12, 2 hydrogens, 2, 1 oxygen, 16. So 12 and 2 is 14, plus 16 is 30. So the empirical mass is 30 grams per mole. But the question says to you, the molecular mass is 60. So 30 times 2 equals 60, which means we must multiply the empirical formula by 2. Okay, so the molecular formula is going to be C2H4O2. And if you check and you work out the mass of this, this is going to weigh 60, and its empirical formula will be CH2O. So this is now your final answer here. Okay, now then in 8.2, it says to you, the molar mass of hydrated sodium carbonate is found to be 268 grams per mole. The formula of hydrated sodium carbonate is Na2CO3.xH2O. Calculate the number of moles of water of crystallization X in the compound. So if we wanted to find the mass of sodium carbonate, yeah, with the hydration, it will be the mass of the sodium carbonate, okay, plus the mass of the water, okay. So this is going to equal to 268. So what we should do now is find out. We don't know what's the mass of the water. We can work it out though, because we know what is the mass of sodium carbonate from the periodic table. So the molar mass of sodium carbonate from the periodic table, if you look here, sodium is 23. So it's going to be 23 plus 23, because there are 2 sodiums, plus 12 for a carbon, plus 16 times 3 for the oxygen. So if you add that all up, you end up with 106, okay, grams per mole. So if you look back here, the total mass of the compound is the mass of the sodium carbonate plus the mass of the water. So 106 plus the mass of the water is going to give us 268. So what is the mass of the water? Is going to be 268 minus 106, okay, and that is going to give us 162. But now this is the mass of the water in the compound, but we need to know not the mass but the number of moles. So we're going to say the number of moles of water is equal to the mass over the molar mass. So it's 162. And water is 2 for the hydrogen, 1 plus 1 plus 16. So it's 162 over 18. And if you put that in your calculator, you should get 9. So the number of moles of water of crystallization is going to be 9. So you should write that down. I've run out of space here. But if you checked here, this 106 plus 9 times 18, this is going to give you 268. So that's how you could go back and check if you're correct. Okay, and that is the end of the question.